Hello everyone. In today's lecture, we are going to discuss about exceptions and interrupts of ARM Cortex-M0. What is meant by an exception? Exceptions are events that cause change to program control. Instead of continuing program execution, normally we'll be having a regular program sequence. Instead of continuing with the program execution, the processor suspends the regular execution of the program and then it executes a part of the program or code other than the main program. That is known as an exception handler. After the exception handler is completed, it will then resume back to the normal execution of the program. So there are various types of exceptions and interrupts interrupts. So interrupts are subsets of exceptions. So Cortex M0 processor supports up to 32 external interrupts. And those external interrupts are mentioned as IRQ, interrupt request, and an additional special interrupt called non-maskable interrupt, which is mentioned as NMI. The exception handlers for interrupt events are commonly known as interrupt service routines. Interrupts are usually generated by on-chip peripheral or by external input through I/O ports. The number of available interrupts on the Cortex M0 processor depends on the microcontroller. Besides the non-maskable interrupt and the interrupt request, that is the general interrupts, there are a number of system exceptions in the case of ARM Cortex M0 processor, primarily for OS use and for fault handling. Each exception has an exception number. This number is reflected in various registers, including the IPSR, and is used, that is program status register, and is used to define the exception vector address. So here 32 exceptions can be handled by ARM Cortex M0, and for every interrupt, a priority number was being given. That is, an exception number was being given. That exception number plays a major role in prioritizing the interrupts and execution of the interrupts. These are the different types of exceptions which commonly we are aware of. One is reset, power on reset or system reset. So if this reset button is pressed, right, then our power on is done. So under these cases, highest priority, the exception number is 1, and so highest priority will be given for that. No other options will be there. So whatever the program has been executed has to be holded, and then this exception has to be executed by the exception handler. Second one is for safety reasons. Some safety interrupts may occur. That is, messages may pop out, or some for critical events or anything. Some information has to be conveyed to us, and these exceptions, these for executing this kind of activities, cannot be given least priority. So, given an exception number 2 for the non-maskable interrupt, that is the interrupts which can never be masked, and so highest priority exception has been given. Next is hard fault, for fault handling activated when a system error is detected. Comes the third. Then SV call, the supervisor call is activated when SVC instruction is executed. Primarily, it is used for OS applications, and similarly for pending services or systematic timer exceptions or interrupts. From 16 to 32 normal interrupts are there other than the special interrupts. So 32 interrupts starting from exception number 16 to 47 was being given. So this is the exception numbers for different types of exceptions, and this exception numbers plays a major role in executing the instructions or exceptions or interrupts. See, this is the normal execution of interrupt or exceptions. So this is the already we have discussed this when we discussed the architecture. So this is the normal program flow. Normally instruction 1, 2, 3, 4, 5, 6, 7, 8. So this is a normal program flow. If at here, if after execute instruction 4, if any exception occurs, then obviously the exception handler, based on the priority of the exception or the interrupt, it will move to the interrupt service routine or the procedure for the exception. After completion of this, meanwhile, what will happen? This address of this instruction will be pushed into the stack. So after execution of this code by the exception handler, it will return back to its original code and then will resume to work. Reset is a special type of exception when the Cortex M0 processor exits from a reset. It executes the reset handler in thread mode. Apart from NMI, HardFault, and reset, all of the exceptions have a programmable priority level. The priority level of NMI and HardFault are fixed, and both have higher priority next to reset of the exceptions. This concept is known as NVIC. Here, if you see here, it can handle up to 32 interrupts. We'll discuss about NVIC in the next slides too. NVIC, if you see, this is a special feature of an architecture we have discussed. That is a feature of ARM Cortex-M0. That is, it has NVIC, nested vector interrupt controller. So if you see the nested vector interrupt controller, 32 interrupts can be executed, right? So once when interrupt 1 enters inside or exception 1 enters inside, and meanwhile if exception 2 enters inside, and suppose if exception 2 has the highest priority, exception 1 will be holded, then exception 2 will be given the highest priority, will be executed. Once exception 2 goes out of the processor, then exception 2 will be resumed back. After handling exception 1 will be resumed back. After handling exception 1, completion of exception 1, it will resume back to its normal position. This is how, with the help of exception numbers, the NVIC, that is interrupt nested vector controller, works. Thank you.